Thanks a lot, Dwarka. I think that's a good prelude to keep people excited. The fact that we're going to have this like live developer session. So I'll run through the way I've set this up is I'll run through a quick, glimpses of what we're trying to do. And then we will access a certain link where all of you guys can do hands-on. So let me share my screen and we can get started. Do you see my slides, Dwarka? Is that okay?
Yes, well, it's visible. You can make it in full screen mode, if
Yeah.
possible.
Yes. So do you see the title and all of that, right?
Yes.
Okay, great. Okay, thanks everyone for joining us. I think it's a Saturday well spent with all the sessions in the round table, and of course Sanchit did a good job in terms of running through the entire home edge stuff, right? So on that note, I'll continue. Like I said, this is a live developer session. We're going to look at how do we quickly develop a Kubernetes operators. And by the way, I'm a quick introduction. I lead the ISV technology aspects from a partner relationship perspective. I'm also responsible for IoT and embedded, emerging technologies within Red Hat. So let's first understand, the very basic thing, right? What is Kubernetes operator and why is it so important, right? And how do we go about developing a Kubernetes operator? That's the crux of this entire live developer session today. So so from a application perspective, from an application development perspective, in the current era where you'll have to, we all understand the fact that ISVs bring a lot of software-driven innovation, right? Irrespective of which vertical or which industry-specific paradigm do you belong to. The most important aspect is how do you drive those customer experience, from a software perspective. So what's very important in the current scenario is how do you deploy it? How do you package it? How do you make sure that it's managed and it's scalable without really emphasizing the anything under the hood, right? The fact that the application has to be intelligent, the fact that the application has to scale, without impacting a shutdown or a restart, things like that. And in underlining everything that turns back and emphasizes the fact that how do I drive a consistent user experience? That's the key. Now, how do we make that possible, right? So an operator is basically how you put all that human operational intelligence, all the knowledge that you have into a piece of software that could understand the way you would package your application, the way you would deploy your application, and eventually manage the state of the application in the desired, whatever desired state that you would prefer to. So that's what operator is. So we're talking about, method, an object that you would define it, and you'll see that in the later part of slides. From a nutshell perspective, it is how do I define the entire human operational knowledge in terms of packaging and deploying and managing an application. And that Kubernetes application is what we talk as an intelligent application, which is capable of, reconciling based on the state of the current operation is. So having said that, let's move further in terms of how do we define this? How do we go about building this Kubernetes operator, right? So we're starting. We all know, even Sanchit mentioned about all the APIs, right? So how do we go about extending the Kubernetes API and implementing? How do we talk to the core, right? How do we talk to the controller to make sure there is a desirable actions that we could take based on object that we would define, right? And all that is possible through what we call CRDs. CRDs is basically the representation of Kubernetes resources, which is more custom defined. So CRD stands for custom resource definition. So you're basically defining your own resources, your own objects, and all of those CRDs then could be packaged into one release, and that extends what is currently available in terms of Kubernetes APIs. And then so now that we have this API extension and we can take certain actions, how do we ensure that these actions are in an approach towards the desired state that we would want it to be, right? And that's where it's important that we have a controller, and that aligns to the Kubernetes controller in terms of ensuring that there is there's a module that watches and tries to reconcile and making sure it has the ability to observe the current state, whatever the running state of that object is, and then it reconciles it based on the definitions, based on the actions that we would like to derive to ensure the application goes back into a desired state that we would prefer, right, based on the application that we put together. Now, and not just this, there's also need to kind of scale your pod and make sure that you're deploying the specific operator into a specific project, like how we define that in Openshift, and it's a namespace when you look at Kubernetes deployments, right? So we're bringing in the API extension. It's also a controller because it has to watch and reconcile, and then it has to go and get deployed to a certain pod in a certain chosen namespace to make sure we know that we have a target namespace at the end of the day, right? Because it's the application that is specific to a particular deployment approach that you have for a particular pod in a particular namespace, within the project, right? So that's how we put all of these pieces together. So we're talking about, a method to package the human operational information and knowledge into how we package it, how we model it, how we deploy it, and all of this is how we go about it. Now, having said that, what else is the key components of a Kubernetes operator, right? How do we make sure all of this ties into the overall, various aspects of Kubernetes to ensure that we have a very well defined emphasis? So we make use of certain Kubernetes resources here, and we also define a certain, Kubernetes resources so that we know what we are doing to. So the first thing that goes is the type, right? So here's where we can particularly find an API group, and then we understand what the version is and how that objects, the object belongs to, right? And this is very important in terms of ensuring that whenever there is a version change or version that you want to, you're building, how do you tag your image to the latest so that the latest release, latest build gets up in the deployment stage, right? So you bring in those metadata information. So there's two types. One is the type metadata, and the other one is the object metadata. And that's where you actually define certain skeletal requirements, like what is the object name, which namespace should it get deployed into, what is the current label, and if you're managing versions, like I said, you can define your own labels with the version numbers and things like that. Now, not just there, we also, like I said, there is a detailed desired state that we expect this to operate in, right? And that's where the spec field comes into picture, right? And you look at what is the desired state, and you make sure you operate that the way it is expected, and all that object definitions goes into the spec field. And finally, there is a need for us to understand whether if all of this is behaving the way we want it, right? And that's where the status field kind of gives us an opportunity to define the current state. Is it red and something's wrong with it? Is it yellow, or is it green, or is it orange, and things like that, right? And that kind of gives you visibility in terms of if you're facing it out, right? And that's more sophisticated, but yeah, that status field could be used for all these purposes. Now that we have the structure, the skeleton, the various resources that we use, now what is that we could do specifically? Sanchit mentioned about some of the crude operations, right? So we could typically bring in a lot of common Kubernetes API features here, right? It could be, like I said, the most widely uses the basic crude operations, and that's possible via HTTP, or you could pretty much do with the kube control, right? The kubectl. And what is also important for us is we tie that up into a couple of very important ones, the authorization and authentication. How do I ensure the extension uses the core API server more from an authentication purpose, and it depends upon how you've deployed it also, right? It could be at the aggregation layer itself. Now, once that authentication is done, how do I go about and do the authorization so that I then tie that up to a specific role within within the overall construct. So these are some of the three very widely used API features that we see. Authentication, authorization, definitely, and then the manipulation that you would do from a crude operations perspective. Of course, you can extend it if there is a need for you to bring in some webhooks from an integration or a notification perspective. You could also tie that up to the various displays in terms of extending it. All of that are potentially possible. So this is what we get. This is what we could achieve in terms of extending the API extensions from a Kubernetes perspective. Now, from a controllers, we all, a few things that I wanted to kind of bring out everyone's attention before we get to the hands-on is to, understand that the controller is in an infinite loop, right? So it's very important that, we track at least one object type, and we can, use the controller to constantly watch and reconcile and watch the current state and reconcile it to the desired state. And again, it goes back to what I mentioned in the previous slide, which defines under the spec field, right? Now, once you've done that, you pretty much control the custom resource definition that you have built, right? The entire object. Now, there might be a need for you to tie that up to external cloud resources. Even that is possible. Again, all defined through the desired state emphasis. Now, if I have to put all this together, we're talking about your CRD, the primary resource that you're defining, and then that goes back and ties it to various secondary resources that is potentially possible through the APIs and being watched by the controller. And some of the most important basic ones that we will have to ensure the overall deployment is successful is how do I tie that to deployments? How do I tie that to the daemon sets and the entire configuration maps we have? And largely, like I said, the stateful sets, right? So that gives you the overall construct of a Kubernetes operator. Now that we've understood what the operator is, what is that we can achieve out of the operator, and what are the different extensions and controllers that we'll have to think about so that it works in harmony with the Kubernetes. So let's get kind of started with the hands-on. The hands-on, there's several ones. Let me take you guys. So you can get started on your laptop. You could go to this URL here, https://learn.openshift.com. So let me take you guys there. I'll give it a minute or two for you guys to get there. And in case you have any issues, please let me know. Okay, I'm here on the, let me see if I can bring this up so you guys can see the URL as well. Okay, so I'm on that link that I shared with you guys. You can get to this particular URL. It's called learn.openshift.com. Now, if you're a beginner, please understand that you might want to get started in terms of the basics and then move towards building your own Kubernetes operator. Now, we're talking about in the hands-on exercise that we're going to do is largely on the Helm based SDK, and then you could also do advanced stuff with using Golang. But if you're basic, if you're a beginner kind of you had to start and you're planning to start, if you just started, my recommendation is to go ahead and do the basic course out here, which is the building operators from OpenShift. This would lead to the Helm one also. So there's several very interactive tutorials here that you could use. All of that is hands-on, and if you're new to entire Kubernetes emphasis, I would highly recommend you to start from the container fundamentals, and that's the foundation. And then you can then depending upon what part of application you are, once you have your container images built, you could look at adding service mesh, make sure you have the observability for your microservices, and you kind of understand which service is impacting which way and things like that. And if you're already advanced, in advanced deployments emphasis, you could also look at, the fact that what we call a serverless, we call that a Knative project, and you could move towards the serverless aspects, also more event driven. Now, if you're working on an application architecture that requires real-time streaming, having the data getting ingested, and all the slicing and dicing that you would do from a data perspective, you could start with the Kafka, right? So the event-driven architecture from a Kafka perspective. Now, if you're absolutely new for everything, go with developing on Openshift. If you're on a monolithic architecture and you want to get started, to kind of break that up, go through the entire strangulation process and have a side-by-side deployment, and maybe prioritize some of the services that you would then want to be converted into microservices, you could start with the Spring Boot. Now, of course, we have a very, Carcass is available, which talks about sub-second performance and all that. So if you're if you're beginning and you want to get started on a Kubernetes native Java stack, I highly recommend to go out with Carcass. And if you're building application architecture again, and for your application, which requires a lot of business processes that needs to be defined, you could look at Cogito also. So these are the tutorials that are available. If you're beginners, if you're kind of just starting with it, my recommendation is go here, get your hands on this, and then take that forward. For now, from a Kubernetes operator perspective, I would get directly to the operators, tutorial. So that would further lead into other several sections, because you need to understand the fundamentals of Kubernetes API. You need to understand some of the components of Kubernetes. So it's, and most importantly, the entire operator lifecycle, right? That kind of sets you up and gives you all the information that is required to even prep yourself in terms of the application that you have and how do you go about building a Kubernetes operator. And remember, when I say operator, there are three types. You could have something which is very basic, something which is intermediate, and something which is very advanced, right? So you could start with a simple Ansible operator that you could automate some of the actions using Ansible. And if you want to look at something which is very at an intermediate level, right? You don't want to code much, but you want to use the Helm charts, then you could talk about the operator SDKs, with Helm. Now, you want to go ahead and look at some of the advanced one. That's where I was talking about using Go, right? So there is operator SDK that you could use with Go and take that forward. And there's several others also, like, for example, if you're looking at Memcached, right? You could use either Helm or Go and get the Memcached done also. So these are the tutorials that are available for you, and you can run them, learn, play with it, do all that modification that you want to do. And in case you want to get started on a complete cluster, that I would recommend at some point of time, I will share the link at some point of time for sure, where you can access the developer sandbox. We have a developer sandbox, and that's available for you. For I think we're doing somewhere around 14 days trial that you could go and I get a sandbox done. So this is where I will leave these links in my slides that we will share with you guys. You could get here and get started. So something that I would recommend you guys to do it, but definitely after going through all these various tutorials. That gives you all the know-hows, all the fundamentals that are required, more from a foundational perspective. And then you would be well versed to kind of go and play and apply these learnings to your specific application. So we're talking about applications becoming intelligent, and that's the need. So having said that, let's get started with our hands-on. I'm gonna, like I said, this whole session is for operator SDK with Helm. It's more like an intermediary, experience that we expect, from the participants. So what are we doing now? I mentioned about various levels and maturity levels in terms of building operators. So you could choose Ansible, you could choose Helm, you could choose Go. And like I said, we use Helm. So it takes about a few minutes for the environment to kick in. And once that's done, we should be good. So what are we doing, right? In this tutorial, what we're trying to do is we're creating a cockroach DB operator. So a cockroach DB is a distributed SQL database. It's built on transactional, and it's a strongly consistent key value store. So you could scale, horizontally. You could attach a persistent volume to it, and you could survive the disk, the machine, the rack, and for any failures, right? How do I ensure that the latency aspects of the disruption is absolutely minimal, and there's no manual intervention. That's the beauty of operators, right? Now, let's get started. So when you click start, it took it takes about a minute or two to kind of set the environment up, and once that is done, you will get to this very interactive space for you to run through it. So I'm hoping all the participants have gone to this page right now. I can wait a quick minute if someone has a question or someone's not able to get to this terminal. If there are no questions, we can get started. So first thing that we do is we kind of create a project. Now, project in Kubernetes emphasis is a namespace. So we know we have a target endpoint to consume the APIs and also deploy the operator, right? So we've now created a project called My Project, and you see those commands here. OC is Openshift console, a new project, and we're defining the name of the project as My Project. So this is very interactive. All you have to do is click and go through and understand, what are the next steps and all of that. I highly recommend you guys to do this. In case you're not doing it right away, please go back and do it, whenever it's appropriate for you, right? At your own pace, for sure. So now that we've created a project, right, we also want to attach persistent storage to it, right? The persistent volume is important because that's when you will understand the state of the application, right? So now that we've created the project, we will go ahead and add, attach the persistent volume. So we've attached PV 2, 3, 4, 5, and 6, which has been mounted and patched to the specific project now. Now we're all set. Okay. Okay. Now what we're doing is we're creating a workspace for the operator now. Within our particular project, right? So we're creating a directory called cockroach DB -operator. You could name it whatever you want under the projects folder, which is in your home directory. So you see that's created now. The next thing we're going to do is to just kind of navigate that and make sure we add definitions like the plugins that we want to create is from a help perspective. And the domain that we're trying to tie that up is example.com. Now you could use your own domains if you have the routes created within the OpenShift project. Now once we're done with that, the next important thing is to fetch the Helm chart. So we have a Helm chart already, and what we're doing is we're fetching that Helm chart to generate the custom resource definition, and that's an API extension. Like I said, it has to talk to the core of Kubernetes. It's an API extension. So what we're doing here is we're using the operator SDK commands to create an API, and by creating that API, we're also aligning it to a particular repo. Right? That's where the actual image is. That's where the actual chart is. Now, once we've created it, we're also attaching it to a certain rules, right? So there, all that definitions that you've done is now considered in the role.ml file. So basically, role.ml file under your configurations, RPAC defines who gets to access, who does not get to access, what is the role, and so on and so forth. And all of this is pretty much tied into the YAML file so that you could do the configurations and things like that. So far we've created a new operator. And how did we go about it? We created a directory. We had, we brought in the Helm charts and created an API so far. Now, remember, you could customize the YAML file for your own definitions, to launch your controller on the cluster and to align it to certain RBAC configurations. Now, you can remember also mention about webhook configurations. If you want to do that, you could do all of that in the configs. Now, the container build file used to build your Ansible operator container image is what is there in the Docker file. Now, we're doing the Helm one. So in that case, this location will be actually specified to the Helm chart. Now, once we're all done, we have the YAML, everything's ready, and we've kind of tied that to the API right now. Now, if in case you want to go ahead and see the YAML and make sure that you specify the specific Helm chart, because the watches YAML is the one which basically observes and reconciles through your controller, right? So you could do that and see what else is available there. Now let's continue. So now this is where we're going to apply the Cockroach DB CRD to the cluster. Now you've kind of loaded up the YAML file, you've loaded all the plugins, the Helm charts, and you've tied it up to a specific namespace, for the domain, and we use the operator SDK to create the API. Now we're talking about how do I apply it, right? So let me go ahead and apply it. So you go to what we call configs and CRDs. Under that, you have bases. And that's where you define the Helm charts, and you basically apply that to the specific cluster that you've logged in. Now, once that is done, once the CRD is registered, there are two ways for you to run this operator, right? You could run it as a pod inside the Kubernetes cluster or as a Go program outside the cluster using the operator SDK. Now, if you're doing it within the pod inside the Kubernetes cluster, it's definitely great for local development, right? You can then manipulate the actions that you want to take. You could watch the state and reconcile and make sure the desired state is available. And you can also report the current state if there's errors, no errors, and all of this. Right? But in this tutorial, we will run the operator as a Go program outside the cluster using operator SDK. And all of this is available in your kube config. So if you kind of go through the kube config, you'll be able to see all of that. So let me go ahead and run this. I'm gonna make sure that the current session is run. So you see all the parts. You see what is the status. You see the logging that is happening for the Elb controller, and you see the message. I mean, this is all configurable. You right now the message is watching resource. So basically, we've created, named the operator. We've attached it to a specific namespace. We've loaded up the Helm charts, and now we've attached it to a cluster. And now we're running it. So that is what we've completed. Now, what is the next thing that I do? Now that all of this is done, right? Let's go and navigate to the specific operator and see what how this whole observe thing happens and what is there in the YAML file definitions. So let me go there. Right, we're in in the operator. Right. So for some reason, doesn't look like I'm able to control the terminal, but this is what I wanted to show is to typically open that up and show, but I should be able to do it with the temp charts. If you see, this is how the definition would be, right? This is a simple ML file that it's showing you the metadata, it's showing you the specs, it's showing you the states. And if you're using replicas to decide how do you scale your pods, you could define that also. And all of this has to be kind of attached to a persistent volume. That's how typically it is. Now let's go see if we could go back to the project and apply this again. And we're going to get the operator now. Okay, so now that we've created and we've confirmed it usually takes some time for the environment to pull down the container image. So let's wait, and then we'll go about looking at the stateful set. Okay, I'm assuming that the container image should be pulled. Let's get to the stateful set. Okay. And now finally we'll get the pods. Okay, the pods are not getting rendered. I believe the image is still getting pulled. Okay, so once the image gets pulled, you should be able to run the get stateful set command, and then you could confirm the pods are running, and you could also go back and check all the pods, right? And that gives you a confirmation that the cockroach DB, the operator, is attached to a particular cluster IP and to which service account. So having said that, let's move to the next step within how do I go about accessing this Cockroach DB web UI, right? Verify that you can have access, from web UI first, exposing the Cockroach DB service as a publicly accessible OpenShift route. Now you should add a route so that the ingress gets, defined, where you could then be able to access that into a web UI from a URL perspective. For some reason, the URL is not getting disposed here. So assuming the URL gets disposed here, you then copy that entire URL, and then you go access that into a browser, and you'd be able to see, how do you go about accessing the Cockroach DB. So that, and then you could manipulate whatever you want to manipulate from the web browser-based UI itself. So that kind of helps you further manipulate, in terms of anything that you want to achieve from a Cockroach DB perspective. So we've seen how do we create, how do you access, how do you define your how do you attach the Helm chart, which has the definitions for CRDs, and then how do you go about deploying the operators. So that kind of brings what you could achieve from an operator perspective. Now, like I said, if you're looking at advanced operators, you could look at Golang also. So that kind of brings to the end of this, and I highly recommend you guys go ahead and do it hands-on. And there's a lot others learning related that you could pretty much go about doing it from the operator framework. Okay, and one last thing that I want to bring to your notice before something very exciting that we've recently put together, and definitely something that I recommend is to look at how do you build the entire pipeline, right? How can I what we call GitOps? How do I commit my codes into once I commit it to GitOps to your master branch, then I can kick in the entire Kubernetes CI/CD pipeline and automate the entire deployment cycle and also manage the application deployment. So definitely recommend it to take a look at the GitOps one. So I don't know if I can go back to the chat screen. So I see if there's any questions. Otherwise, we're good, Dwarka. Looks like we've got good time here.
Yeah, so far we don't have any questions. There was one question when the homepage presentation was going.
Okay.
I believe it was for them.
I can't see. Let me stop sharing and go to the chats. Okay, I don't see that. Yeah.
Okay, so the question, if Suresh is still on the call, maybe either of you can answer. So the question was, can we host the data services on Kubernetes? Do you have any example? Suresh, Sanchit, Niranjan, are you guys still on the call? So I think they are not on the call. Sanchit, I can see. Sanchit, you are in mute. Okay, maybe whoever's asked the question, I request if you can post this question in the homepage community, which was displayed by those folks. They will be happy to answer. I will also pass on the question to them after this event. There are no other questions. I think people are still trying to understand what you have shown them. It might take some time.
Yeah,
Vinay, you're there?
so yeah, I can hear you, Dwarka.
Yeah, I was telling it might take some time.
Yeah. So this is a bit of intermediary, right? So if they're beginners, probably, yeah. So my recommendation is to go to that URL and start the beginner hands-on also, and then move towards the intermediate. And if you're looking at advanced stuff, like I said, go to the operator SDK on Go.
Right. That was really interesting. I mean, though we are in the virtual world today, I was not expecting that we will be having some platform where we can do pair programming together while you're sitting in your home and I'm sitting here. That's really nice.
Perfect. So
yeah, Vinay, go ahead. Would you like to conclude your talk?
yeah, I think I had one more thing to share.
Yeah.
And let me share my screen. I think I definitely want to take the participants through the developer sandbox so that they could understand. I'm not sure if I'm going to go back and share.
Go ahead.
You see my browser window?
Yes.
Okay, perfect. Okay, there you go. So you go to developers.redhat.com. And if you go to developers.redhat.com, I'll include this link also in the slides so that we could share it with all the participants. Now, here's an access to a lot of developer resources, right? Everything that you would need to, kind of build your applications, or if you're in a process to modernize them from a microservices perspective. Now, if you have just the WAR files, right? If you have your source code and if you're looking at converting them into an image that you could then plug and play from an a containerization adoption perspective, you could use what we have, source to image. Now, this source to image is a feature that's available, and you could play with all of that with the developer sandbox. So if you get started on this developer sandbox, you could create your own cluster and get started and use the source to image, where you could quickly get it's more like a lift and shift kind of a thing, where you take your WAR file and then build an image out of it. And we have images like the UBI, the universal base image. That's something that you could tie it up with Red Hat technologies or non-Red Hat for that matter. And you could start with the UBI image, and UBI image comes with various form factors. And we've just released a micro form factor, which is very, very lightweight. Could work with some of your edge deployments and things like that, and get started for there. And all of these are OCI compliant now. Ever since Docker enterprises are happening, there's a need for some kind of an open standard to ensure all these images work from a container engine perspective. So all of these are OCI compliant. And if you start with the UBI, you'll be able to build your entire container image and take it from there and use S2I to build it. And what we've usually seen is, from a modernization plane, we've seen folks start with their existing application, use the S2I to build an image, And then from there, they go out and adopt containers, all the benefit that you get from a portability, flexibility, scale perspective. And then they start to the strangulation process, right? They identify, and these are something that is like a side-by-side deployment. So you're not disrupting your existing customers. You're making sure that you modernize the application one service at a time, and then start making the best of the logging feature, the monitoring feature, and so on and so forth that the platform has to offer for you. So you're making your application more intelligent. You're building the operators so that you could then package all of that and deploy that. So this is another important thing that I wanted to quickly share with you guys. Um, and if you're building it, for example, if you're building it on OpenShift to be precise, you could then deploy it on AWS or Azure or IBM Cloud and so on and so forth. So you're truly bringing in a very consistent experience for the developers, for the your operations team, and to your end customer, irrespective of which public cloud that you are in. And what that means is, you don't have to really build specifically to a certain public cloud. You could have on-prem as well as any of those public clouds, which means it's a true hybrid approach that you could enable from an application architecture perspective. So all of this is absolutely important from a developer perspective. And how do you really modernize? How do you really adopt what we call cloud native, Kubernetes native intelligent applications?
So Vinay, there is some basic question.
Sure. I might have to stop my.
No, it's okay. It can still be there, no problem. The question is, how can we use this platform to modernize the legacy telco monolithic systems to microservices or containerized services?
Very, very good question. Now this depends upon what is that legacy telco workload that you have. Now, if there is, if there is what we call VNFs, right? I know Arpit mentioned, and Timo also mentioned the influx point of moving from VNFs to CNF, right? The virtual network functions to now cloud native functions. So we have it all depends upon what exactly that legacy telco is and how much of dependencies it has from a network hardware acceleration part of perspective. And we at Red Hat, to be specific, we have a joint lab with various ISV global ISVs, and what we can do is to bring you on that modernization. From a OSS, BSS, we already see that modernization happening. And again, it goes through the same strangulation process. I don't know if you guys understand strangulation process. So what we do there is we quickly adopt Spring Boot and prioritize which services you want. That's more a non-developer, but more a business orientation to say that this is a service that we can achieve as the first step towards it. What I've seen more or less is the UI. That's the service that I see most of them want it to be modernized, and then they expose their core in the form of APIs and still kind of access it from the UI layer, right? So that's a typical one that we've seen most of the time. But otherwise, it's all business call, which services that needs more attention, which services has more interaction towards the end customers, plays more important role. But first thing that you would probably look at it is from a larger perspective, what are those VNFs and how do we take them towards the CNF? Now, there is a special workshop that we have, and I could probably, whenever that happens, I could share that for all the IEEE members, and then later on take it from there.
Thank you very much, Vinay. I think you have elaborated the question very well. We had an advantage of some time, so you were able to answer it in detail.
Right. We could, yeah. And my recommendation is definitely go through the fundamentals. If people are beginners, then understand the fundamentals, and then all the modernization play also becomes easy.
Yeah, in fact, you brought a very valid point. If we look at all the sessions that we started early in the morning today, so we go through Timo and everyone. the way the migrations are happening, the transformations have been done, I think one has to go back all the way to the 6-7 years of journey the telecom industry has promoted into digitalization and containerization and all those things started. So it might be all the way to the basics, why it exists, which module, which solution, how to deploy. I think the answer lies in all those historical things and timeline.
Yeah, and most of the vendors are also moving that way. So there's tremendous pressure, not just from the operator perspective, but the vendors are also moving there. So we're at the inflex point right now, and it's just a matter of time.
In fact, I would like to add one thing is if we have to compare with the legacy telco and the modern telco system. In the legacy telco system, as we all know, I mean, not just legacy or modern, but any telco system, there are so many modules and components involved. And there was an era when operators used to get locked with certain vendors due to some reasons. But now there is a diversification and multiple modules are coming from different vendors. And this open source platforms are making a way out to interoperate and to deploy it at speed very easily.
Absolutely, absolutely. And there's a lot of criteria after that also, right? I mean, now that people are aligning to that, there is a need for you to understand your existing code. So there's a lot of discovery that you'll have to achieve to ensure that one of the portions can be, just re-platformed, and some of them could have to be, completely refactored, right? So you go through that entire journey to say, hey, this is possible, this is not possible, and wherever you'll have to refactor your codes and probably even recode and things like that. That journey has to happen. It's not straightforward, I would say.
Sure. Thank you. So regarding the question that was asked for the homemade session, Sunchit is on the call now. Sunchit, would you like to quickly answer what is this current status so that the
Yeah.
yeah.
So like currently we do not support Kubernetes, but like we are planning to have a cloud sync mechanism in place. So we'll be considering GK, Google Kubernetes engine for that then.
Yeah, perfect. And as I requested, feel free to join the communities that Sunchit has shared, the website that Vinay has shared, so that you guys can get into more conversations with them and other members as well. So thank you very much, Vinay, once again.